Alright, so this is for the law of sines section here. Right up top here, this is just one of our word problems that I'll be using below. So specifically, law of sines, aside over the sine of the angle matching to it. So you're creating three different fractions that are all related to each other. So if you had your triangle, and this is angle A, side A is across from it. If this was angle B, side B across, and around like that. We can create three different fractions. This can be used in situations where we know two angle measurements and one side length, or if we know the length of two different sides and the measure of one angle that is not between them. Alright, so the first example from the word problem above, we have this triangle here between the two people. They're trying to find out how far it is to get across this lake, so I'll just call that side X. When given in the information, the angle here is 88 degrees. This angle would be 44 degrees, and the person walked 100 feet. So to make life easier, I'm just going to label angle A, angle B, angle C. Call that side A, B, and C. So now to be able to try to find a missing side, we can use our law of sines. So I could say that C over sine of C is one thing. And that would be the same as A over sine of A, which is equal to B over sine of B. Now in this, we know what C is. That's 100. Angle C we can find because 88 plus 44, subtract that from 180, so that would get us 48 degrees. And then we know what the sine of B is, which is 44 degrees. And then we are looking for side B, which is X. So now to be able to solve this, first step, we can cross multiply 100 times the sine of 44 degrees equals X times the sine of 48 degrees. Get X by itself by dividing. We have 100 times the sine of 44 degrees over the sine of 48 degrees. Alright, this portion right here we can actually just type into your calculator to get an answer. So when we type 100 times sine of 44, we'll get some value divided by the sine of 48, and that would come out to be 93.48 for the distance across the lake, or for our X value. Right, the actual calculations here are not going to be any more than what we're doing right there. Now, because it's pre-calc, we got to make life harder for you. When we talk about solving triangles, that means we need to find all three sides and every angle in the triangle itself. So you're going to need to tell what all three sides are and what all three angles are. All right. In all of these triangles coming up, there may not always be a solution. So there's three options that could happen. The triangle may not be possible, or there's no solution. There may be only one solution for the triangle, or there could be two unique or two different solutions. In all of our triangles, here's the conceptual part about it. If we're given the length of two sides, we're just going to refer to those as A and B. So you know the length of two of the sides, and you know the length of one of the angles. Now what I mean by angle A is, if I know the measurement of one angle, and they told us the measurement of one side that is across from it, A, and then they gave us another side, I'll just call it 9. This is what I mean by an example. I know there's a 9 and a 16, and the cross from the 16 would be 48 degrees. And then there's different possibilities of what could happen. If the angle they give you is obtuse, there's two possible situations. If angle A is obtuse and the side across from it is less than B, then it is not possible to have a triangle. The reason for that is, if I drew this out and this was my angle A and it's obtuse, so it's greater than 90 degrees, if this is my side B and B is going to be longer than A, well, if A's not going to be long enough to reach it to the other side to complete my triangle. That's why it's not possible. Now, on the reverse, if they give you angle A as an obtuse angle, and side A is longer than side B, then it is possible to have a triangle, but there is only one possible situation where a triangle can be made. That's pretty straightforward. Now, what if angle A was acute instead? If angle A was an acute angle, now's where we got a couple different options of what could happen. Alright, so if angle A was acute, and I'm going to refer to everything here in a little bit of a different form. So my angle A here. So I got an acute angle for A. Now, the way we can determine which of these four situations will occur, if I take side A and then compare it to side B times the sine of sine A. So again, if you have a side B, multiply by in your calculator sine of angle A, and it'll give you some value. So if A was, say, 3, B was 5, and sine of A was, 32 degrees, you would do 5 times the sine of 32 degrees, get you some value, and then see how it compares to A. If when you get this value, it is exactly the same as sine A. So sine A times B is the exact same value as A. What you've ended up creating would be a right triangle. There is one solution, one right triangle solution. Now, if A is an acute, and when you multiply B times sine A, if this value on the right hand side, B times the sine of angle A, gets you a value greater than the length of side A, then it is not possible or no triangle can be made. And this is all based on sine and cosine, opposite over hypotenuse. That's where all this comes from. When this is angle A, this is side B, and you're comparing them that way. So for all these cases, you're just going to do a quick calculation, compare it just to know how many solutions there could, would, or should be. If you take angle A, or the angle they gave you, multiply by B, if that is less than side of A. So I got angle A down here still, I got side B. This is my side A over here. So if when you compare them, B times side of A is less than A in the initial, if that value is less, then one of two things can happen. If A is greater than B, there's one possible solution. But if A is less than B, then there's two possible solutions. And now I'll try to show why there are two possible solutions. So if I have right here, I have my triangle. Here's my acute angle. Alright, so we have our triangle right here. This is what it would look like if A is greater than B sine A, but side A here is less than side B. This makes one triangle. However, I'm not changing this angle A. I'm not going to change here, but I could rotate this and move it over, and it is possible to tweak it a little, create a completely different triangle where A has the same angle, B and A have the same length, but it's now a different triangle. So C over here would be a different length, and this angle up here for capital C would be different. So these are your situations. This is only going to help you just to know how many solutions you're trying to calculate. So now for our examples here of how to actually use that. So for the first example, I'm going to go over here. They gave me what A is, they gave me what C is, and they gave me angle A. So I can think of C as the same as, this would be my B times sine of A right here. Or 20 times the sine of 112 degrees. All right. So when I multiply that out, I'm going to end up, all right, so when I multiply that out, 20 times the sine of 112, that's going to give me 18.54. Now when I compare that to 32, that's less than 32. So now looking from, if I go back here, if I look at my rules, B times sine A is less than A. I got to compare, is A less than B or is A greater than B? Well, A is greater than B. Alright, since A is greater than B, scrolling back down, since A is greater than B, there's only one possible solution set here. So that means there will only be one set of values. So A will have a value, B will have a value, C. Angle A will have a value, angle B, and angle C. So I only have one set of answers that I need to find. A, they tell me, is 32, C is 20, and A is 112 right here. Now we're going to do exactly like we did on the first page to find the remainder of the values. I can use my law of sines. So 20 over the sine of C will be equal to 32 over the sine of 112. All right. So 32 times sine C equals 20 times sine of 112. Alright, so we already did 20 times the sine of 112, that's 18.54. So the sine of C is 18.54 divided by 32. Sine of C is 18.54 divided by 32, which is 0.5794. To actually find angle C, we need to take the inverse of that amount. Inverse of that amount gets me 35.4 degrees. 35. Alright, we know two of our three angles, so subtract them from 180. And we would have for our final angle 32.6 degrees. And now we can repeat our process for the law of sines one more time to find our missing angle. I'm running out of it. So B over the sine of 32.6 equals 32 over sine of 112. That gets me 32 times the sine of 32.6 all over the sine of 112. That will get us our B value, which for this one, B comes out to be 18.59. 18.59. Alright, and our second to last example problem here. On the left, they gave me what angle A is, they gave me B, they gave me A. So B, or 18 times the sine of 63, we need to see how many possible solution sets there can be. That's going to give me 16.03, which is less than 17, or A is greater than B times sine of A. Now I need to compare which is larger, A or B. Well, A is less than B, so that means there are two unique or two possible solution sets. So there's two solutions. So I have A, B, C. Here's your first solution set. Angle A, angle B, angle C. And then my second solution set would have to go over here. A, B, C, angle A, angle B, and angle C. Now, the angle won't change in either solution set. So for angle A, or what's given to me, that's not changing at all. B is still 18 in both of them. And A will be 17 in both of them. So the first thing, just like on the front, we need to find for this first set here, what is C, what is A, angle B, what is angle C. So I'm going to go with 17 over the sine of 63 equals 18 over the sine of angle B, or sine of angle B is going to be 18 sine of 63 all divided by 17. Alright, So that gets me, when I multiply all that out and then take the inverse, angle B will come out to be 70.6 degrees. 70.6. Alright, we know our two values. I can subtract them from 180 to get my third angle of 46.37. And then use the same law of sines again. 17 over sine of 63 equals C over sine of 46.37 to find our third side. So C would be 17 sine of 46.37 over sine of 63, which would bring our third side out to be 13.8. Now, as I said earlier, we have two different sets though. We need to also find our second answer set over here. The 17 and the 18 don't change, the 63 over here won't change. Now, the one thing that does change though is right here, this angle that they gave us, since B was given to us, but the angle paired with it was not, this is what we use to be able to get our whole other side. All I'm going to do is take 180 and subtract that 70.6 from it. Alright, so that means, I'll just give myself some space here. That means that angle B will be 180 minus 70.6, or angle B will come out to be 109.4. So now I have 63, I have 109.4, so angle C will come out to be, for the second option set, 7.6 degrees. Well, now I just need to find what side C will be for this third set, or C over sine of 7.6 can be the same, equal to 17 over sine of 63. So C is equal to 17 sine of 7.6 over sine of 63. When we type that all into our calculator, that'll come out to be 2.52. So 2.52 for our final set right there. Alright, so those are some examples here for you. There's two more problems right here for you to try on your own. You can hit pause on the video, you can hit stop, and I will show the work here in just 1 second. Alright, and here are the solutions for the U-try here. Alright, on the first one, I know they give us B and C, they didn't use the letter A, but using that same formula, just treat these as A and A. B times sine C gets you 15, gets you 11.49. That is less than the value of C, or it's less than 13. So that means I now need to compare C, B, is A greater than B? It is less, so there are two solutions, and these are what your solutions will come out to be. Over here, when you check it out, B times sine A gives me 37, which is greater than A, so it is not possible for a triangle to be formed. So that there is our lesson for the law of sines.